Okay, cool. Today our focus is going to be on parts of a triangle. In a triangle, we have all different things that could happen. You have a median, an altitude, an angle bisector, stuff like that. There's two of these four that we're really going to focus on today. The two that we really care about are 1 and 3, the median and the angle bisector. I'm going to bring up the altitude and I'll show you what it is. And I'll bring up the perpendicular bisector. I'll show you what it is, but we're not going to do a lot of problems with it today. Is that all right? Just those two. Now a median sounds like what? The middle. The median is a segment. The median is a segment that connects the vertex and the midpoint. Maybe I can say the opposite midpoint. In a triangle. So for example, right here, that's the vertex. This roughly is the middle, right? If it's the middle, I'm going to put those two little tick marks on there so that I know it's the middle. And a median would connect that vertex to the middle. How many medians would be inside of a triangle then? 3. So there's 3 vertices, which means I have one that starts here, ends roughly there. So it's something like that. Now, interestingly, all of the medians match up at one point. That one point is called the centroid. Although I don't know that we need to know that. Now this is a cute triangle, or at least I tried to make it cute. If you're ever not sure, sorry, what? Is it cute? All right. If you're ever not sure though, let's find something. Let's find something that, oh yeah, look at that. Is it cute? No, we had kind of a teacher screw up. That's not a cute, that's obtuse, right? No, well, sorry. It's supposed to be. All right, the next one. A median can happen on a right triangle, all 3 sides. A median can happen if I do one right here. Now the kind of question you'll be getting from this triangle, or from a median. You okay? I have water, do you have a water bottle? You can't leave, but I can give you one. Okay. So the kind of question you'll be seeing with this is, if it's a median, and this is x, and this is 8, do we know what x equals, or could we figure that out? Well, if it's in the median, it's in the middle, it's half, right? So what would x have to be? It has to be equal to each other, right? Tick marks equal to each other. Notice this one has 1 tick mark, these ones have 2. That means these 2 are equal, but they're not equal to that one. Okay? Alright, so if I were to highlight kind of the key word in the definition, what would it be? Segment connecting the vertex and the midpoint of the opposite midpoint. What's the key word here? Midpoint? Is that alright? So let's talk about an altitude. The altitude is the height of the triangle. So when you're doing like area equals base times height, that's the altitude that you're using. Now, the height is a segment. that crosses so the height is a segment that crosses the vertex and it hits that opposite side at a 90-degree angle. So right here, it's going to come straight down. It's kind of hard to draw. This one, from the vertex, those would be the 3 different altitudes. Now, on a right triangle, though, where would the altitude be? On a right triangle, what is the altitude you want to decide? Does it hit 790? What about an obtuse triangle then? On this one, on the obtuse triangle, on this angle right here, if I were to extend this side, my altitude comes on the outside, and that would be the altitude. Yeah, and if I were to draw all of them, so like on this one, like under that, this one the altitude kind of comes right here. Don't draw this part. If I were to extend these, the intersection wouldn't happen. I'd have to extend this. No, extend this one. So the intersection's not happening until like clear down here. But this is the altitude on an obtuse triangle. It's on the outside. Like this? No, from the right here? Yeah, this one can. This is an altitude. Right here. No, not necessarily. I'm just stating my whole point is, if I were to draw all the altitudes on this triangle, this altitude, yeah, that can hit at a 90 right there. But this one, if I try, can I draw a 90 that's going to come through the triangle? No, it has to be on the outside. Likewise, this one, I'm not going to get a 90 going inside the triangle. I'd have to extend it out here, and my 90 would be right in that range. So if I were to connect all 3 of these lines, it wouldn't connect until clear down here. That's just a, wow, that's nice to know. Who cares? Move on. Kind of thing, right? Okay. It's not something you're going to be like tested on. It's just interesting. Okay, angle bisectors. Oh wait, back up really quick. What in this definition do you think is kind of a key part of the altitude? The 90 degrees. Yeah. Oh. Try again. Look at the eraser and the highlighter so close together. Really easy. Angle bisector. Sorry, what? It's this angle right here that has to be right. That angle. Okay, so there's only one in that one? So if I just, so this one, each of these purple lines is an altitude. Don't worry about altitude. Promise, we won't do that. Moving on. Angle bisector, this is the other kind of key one we're doing today. So what does bisect mean? Cut it. So the sec part means cut. The bi part means 2. So I'm going to split, or I'm going to cut the angle in 2 equal pieces. How many angle bisectors will there be in a triangle? 3 again, right? So, what would the markings look like? If this is an angle bisector, what would I put there so that you know it's an angle bisector? It's called an arc mark, not to be confused with an aardvark. So those are arc marks. I'm going to put them there so I know that those 2 angles are the same. Last year I had an aardvark on my computer screen for about a month because of this whole thing. Angle bisector, although that doesn't really look like a straight line, just use your imagination. Angle bisector. These ones are considered more raised because they come outside the triangle, but it doesn't really matter. They just stay in. And yes, again, it happens on all of them. You're just looking for that marking. On this one, okay, that doesn't look like it at all. Try again. Something like that. So the kind of question you'll see for these problems is you'll see that maybe the entire angle is 30. What? That part of the angle? It would have to be 15, right? It would be half as big. Because each of those little pieces are equal. That's different. You also have a perpendicular bisector. Well, perpendicular means what? It's crossing at a 90. Bisector means it's cut in half, right? So this is what it would look like. If it has to hit at a 90, I'm struggling with my straight lines. It's the board, I promise. If it has to hit at a 90, it's going to kind of be right there. If it has to be cut in half, it's going to be through the triangle. Now looking at the three of them, the perpendicular bisector is the only one that does not go through the vertex. Everything else does. So that's what a perpendicular bisector is. If I were to define it, I would say it's a line or a ray that crosses at a what kind of angle? 90-degree angle. That's how I get the perpendicular part. Maybe starting at where? What kind of point? What point is this? The midpoint? Is that okay? And again, all of them have it. This one, this is about in the middle, equal, goes straight up. That's a perpendicular bisector. Is it a median? Now, if I wanted to change it to a median, I'd have to connect it to the vertex. So the pink one's a median, the red one's a perpendicular bisector. But again, our focus is on angle bisectors and medians. Those are the two that we really care about. Any questions so far? We haven't really done a whole lot. Okay, next page. Yeah. Okay, so question A. The first thing you need to pay attention to is what kind of section is there? I have a really bad habit of ignoring this line right here and jumping straight to that one. So that top line tells you exactly what you need to do, right? Be really careful not to just jump there. So we are told that this is a median. If it's a median, what do you know about these two pieces? They're equal. So find SM, this part right here, that's where I'll put my variable. Find SM if NM is 24. Now this is how I like to look at it. SM, is this a half or is it a whole? A half. If it helps you, mark it. Now these need to make a little bit more complicated than maybe they need to be, because that will help us with part D and E. So SM is a half. NM is a whole, yeah. What would I have to do to my whole in order to get the half? Divide it, right, in 2. So SM equals what? It equals what? Radian. Yes. Yes, it does. Okay, find XG. So half or whole? My half. If SG, half or whole, equals 2. Well, if the whole equals 2, and I only want half of it, how big is my half? Now, notice with these ones, did I put that little segment head on top? No, the notation for this says, without anything on top of it, I'm talking about how big it is. Remember when we do angles and we put that little M in front of it? That means how big is it, right? Without the little line right here, that means how big is it. Okay, next one, try it on your own. Find JB. If JB is 6.9. JB is the half, JD is the half, so they have to be equal, right? I like doing problems like this first because numbers you're very familiar with, right? You know how to set two numbers equal to each other. You know how to divide two numbers by 2 or double something, right? Let's throw some variables in now. We're going to do this, we're going to come about it almost the exact same way. Except we're going to take a little bit more algebra to get us where we want to be. So on this question, find x if PR, now really quick, PR is that a half or a whole? That's the whole. Is x plus 9. And FR, half, is 2x minus 3. Now let me tell you one thing. When it comes to variables, it's a lot harder to divide than it is to multiply. So I'm not going to take my whole and divide it in 2. Instead, I'm going to take my half and do what with it? I can double it, right? So my half, if I multiply the half by 2, do I get the whole? Now the letters, like with the variables in there, it looks a little bit different. The whole is x plus 9. 2 times the half would look something like this. Now this expression looks different than this expression, right? But once I do the algebra to solve for x and plug them back in, I should get, for example, 8, 8, and then 16, depending on what the numbers are. Does that make sense? So right now they look different, even though I've set them equal to each other. If I plug them back in, we would notice that they're going to be the same thing. We double the half and set it equal to the whole. Yeah, and now we're going to solve it. So we start by distributing. I can't combine those middle terms right there, right? Because one's a variable, one's not. So we'll distribute 4x minus 6 equals x plus 9. Subtract the x. Now I'm only going to subtract things over if one's on one side of the equation and one's on the other, right? If they're both on the same side, we just combine like terms. That's a very common mistake, so just be careful. And because of lack of room, I'm going to do this all in one step. Is that okay? Nobody's brains are going to go on into that. Okay. So 3x equals 15. What does x equal? And if I were to plug that back in, the entire thing would be 14, right? Which means that should be 7 and that should be 7. Is that okay? Let's check. If I plug 5 in right here, 2 times 5 is 10, minus 3 is 7, right? So it works. Yeah, that's a really good way you could check yourself, is to plug it back in. Let's make sure everything kind of filters out the way it's supposed to. Okay, let's try the next one. Okay. Find x if hx, which is right here, half or whole. This is half. And hy, half or whole, half, are those two different things. What do we know about the two halves? They're equal to each other, right? Because they're both half. So this x minus 4 and this 2x minus 11 must equal each other. Good. So again, they look different, but once we solve it, but the important thing to know is that you need to pay attention. Do I have to double it to set it equal to the whole, or am I just given 2 little pieces?
If we could have all the dogs come back to the commons, teachers at this time, if we have students that need to use the restroom, please let them do so. Remember, only one at a time. If you do see a dog in the hall, take a white bird, and please refrain from coming down to the commons for a while. Thank you.
A wise bird. Forgive me, space. Don't try to feed them a snack. They don't need that. They know who their owners are, that's for sure. Okay, cool. Any questions with that? Do you want to try the first 2 on your homework? Let's make sure we're all on the same page. Let's do that. First 2 on your homework, if you haven't already done them. Who's already done them? try the first one on your homework. Let's make sure we're on the same page here.
So the first,
there's one last one. I did, right? Unit 2, my first unit was Unit 2, like the homework. It's so hard as a teacher. I don't want to give you too much homework because I don't want to hate you, right? So I need to give you enough that you understand how to do it, right? I feel like this has gone a little bit not quite enough. But so that means if you only have 2 times to practice this, let's make sure you understand it because you're not going to practice it again until we take a review at the end of the unit, right? Oh, dang. Welcome. Were you hanging out somewhere because of the lockdown? Were you hanging out somewhere because of the lockdown? Okay, we just got out of the lockdown. Yeah. Did you see the dogs? Are there a lot? Yeah. They're probably just training the school in the city. Or somebody has drugs in their locker and they're looking for them. One of those two. Right? Yeah? Do you want to see my, hold on. I don't remember. Okay, take a minute. Right? I can't stand it. I think I'm done having children, but when I see these cute pictures, I do not want any more babies right now, but they're so cute. I love them. They all have, her eyes are, not that this has anything to do with our lesson. Her eyes are close together. She has more of my husband's shape right here in her face. But their noses, those are all mine. Oh, yeah, and their cheeks. Okay, sorry. Keep going. What was I doing? Oh, I remember. Sorry, I'm just trying to get the picture up. Okay. The first one's a little bit tricky because I think the 10x on both of them are a little people off. So let's look at these two right here. Looking at number 1, find x if UW, is that a half or a whole? It's a whole. And EW. EW is the what? Half. So what do I do to the EW? I have to double it. 2 times what? X plus 3 equals the whole, which is 4x minus 6. Is that okay for number 1? We double the half instead of equals the whole. So we would get 2x plus 6 equals 4x minus 6. And then you would do a lot of algebra and you would get x equals something, right? Is that okay? And then skip that, do a lot of algebra steps. Depends. So I doubled this one, right? And I got 2x plus 3, so I doubled it. And I said it's equal to the whole, which is 4x minus 6. Is that okay? Yeah. Okay, let's move to the next one. The next one, so that's number 1, this is number 2. EW, just kidding. You see right here, half or whole. That's the whole. LT is the half. So what do we have to do with the half? Double it. So 2 times, how big is it? 10x minus 5. So 2 times the piece, the half, equals the whole, which how big is the whole? Good. Now once I solve this, let's distribute. Bless you. And x minus 10 equals 3. So we're going to get a decimal on this one. Is that okay? Sorry, I'm really just we get a decimal. That's all right. Now, I told you that be careful of decimals. I mean, you don't see them very often, but maybe you're going to start seeing them a little bit more. Okay, cool. Did you see that, or is it zero? Okay, let's go back to our notes. We're going to practice this some more, but we're going to practice it with angle bisectors this time. Moving on. P.S. Will somebody remind me to mark down to put their phones away today because I forgot. Okay, problem A. We're going to do the same thing, but we are doing it with our bisectors. Find the measure of UST. UST, is that a half or a whole? That's the whole. If angle 2, half or whole? Half equals 36. So what am I going to do to that 36? I'm going to double it, right? Because it's only the half. I'm looking for the whole thing. Let's do it again. Angle XZY, half or whole? Now, almost always, if they name it with the letters, they're talking about the whole thing. You have to be careful, double check, but almost always. Angle 2 is the half, right? If I'm given the whole, and I only want the half, what am I going to do with it? Ashley, what did you say? We're going to divide it by 2. Good. Somebody earlier said, well, what's the difference? Why did I double it here but divide it here? And it's all the point of reference. If I said that I'm twice as old as you, and you know your age, what are you going to do with your age? Double it, right? But if you know how old I am, what will you do to find yours? Half it, right? Not angle 1, but it would be like M angle USD equals. I just make 72. As long as the 72 is there, I'm happy. Okay, so try part C. Let's make sure you do it right. So you could half it, you could double it, or it could be equal, depending on what you're looking for. Angle BCC is 48. Find angle 2. Make sure if I don't see the answer, it's going to come back. Okay, this is the whole, right? If I know the whole and I'm trying to find the half, what do I do? We're going to half it, right? Divided by 2. 43. Okay, now let's do the exact same thing, but let's do it with some variables, with the algebra. So find x if the measure of angle 2, by the way, angle 2, half or whole? Is a half. Is 9x plus 2. And angle 1, half or whole? This is half. Is 8x plus 6. We're given two halves. What do I do with those two halves? They equal each other. Two halves equal each other. So we don't have to do anything crazy. This half and this half are equal. And now you just solve. Subtract your 8x. X. Subtract your 2. 4. Now make sure you go back and you look at what the question's asking. If the question just says find x, you're done. If the question says plug it back in, find, measure, whatever, then we would plug it back in. So make sure you're checking for that. Okay, last one. Okay. Sometimes it might ask for like this one, if it said find the measure of ESD, we would plug it into one of them and then we have to double it. Then we plug it into one. And then we ask it. Okay, try E. Let's see if you can get this off by yourself. Okay, when you have the answer, put your finger out on your camera and check. So if you've already gotten it, pull it out. Alright, angle 1, is angle 1 half or is it a whole? It's a half, right? PRS is a what? A whole. So what do we do with my half in order to equal the whole? We double it. And if you want to just double it as you're writing it, you can. You don't have to write the 2 and then the distribute. Is that okay? You just double it. Equals 11x plus 3. Subtract your 10x. Yep, so 8 equals x plus 3, which means x equals, the question says find x, so we are done. Good, let's move on. We have 2 more kind of ideas today before we're done. No one, mid-segment. What does mid-segment sound like? Middle. It's kind of like a midpoint, right? In this case, it's a mid-segment. The mid-segment is a segment that connects the midpoint of 2 sides of a triangle. Which means G right here is the midpoint. I is a midpoint. So this is one of the midsegments. There's 3 things you need to know with regards to the midsegment. That's one of them. The next one is that the midsegment is parallel to the base. The last thing you need to know, because it's in the middle, it's half as big as the base. So the mid-segment is the base divided by 2. Half as big. Or you could look at it this way, 2 times the mid-segment would equal the base, right? Which means if this is 8, what would I do to find the bottom? I double it, yeah. So this would be 16, which is part of your assignment today. So I'll get that. Are you ready? Okay, for number 8. Oh, really quick. This is all 3 mid-segments drawn together. So if I draw all of them, so this is a midpoint, that would be a mid-segment, this is a midpoint, that would be a mid-segment, something that, oh, that's interesting, but you don't really need to know. All 4 of these triangles are exactly the same. It breaks it up into congruent triangles. So, oh, interesting, but who cares, right? No, I do. You don't need to know that, but it's interesting. Okay, number 8. In each triangle, M, N, and P are the mid-segment, or the midpoint. Name the segment that is parallel to the one given. So given MP, which side would be parallel, or which base? HI, good. Way faster than my last time. So those are parallel, right? Given NP, which base would be parallel to that? Do you need the little line over it? Yes, because we're talking about the segment, not the measurement. Those would be parallel. Good. That was quick, I hope. Last 6 problems and we're done. With the mid-segment, if SU is 10, find HI. Sorry, we're on number 9. 9, yep. If SU is 10, what will HI be? 5, because it's half as big, right? If XZ, that's a 16, can you tell? Is 16, how big is CP? Oh, that's pretty. If UV is 9, find EG. Why? Because we double it. Why? Because we half it. Half we double. Let's do the same thing this time, but with with variables. So how is EF related to IK? Big. Like how big is it compared to? EF is what? Half as big. So what would I have to do to EF to get the base? Yes. If I want to know how big the base is, I have to take the half and do what? Double it. I know that you guys are so ready to be done. Yeah? Oh. Wish you could recreate it for all. Okay, so if I want to find the base, I'm going to take that middle and double it, right? So 2x plus 17 equals, now do I have to double the base? No, the base is already twice as big, so I just, I double the small one so it equals to the big one. So distributing this, 2x plus 34 equals x plus 27. Subtract the x. X plus 34 equals 27. Now I want you to go back and check. Was our goal here to find x, or did we have to do something else? Something else. We don't want to find x, we want to find yes. So we're going to take that add negative 7 and do what with it? Right here. It's got to go right there, right? If I plug it in, I've got negative 7 plus 17 equals what? 10. Let's do it again. What do I do here? Now, technically, this is where a lot of people get confused. See how this is a 2x and this is a regular x? They think that because that's a 2, it's already bigger, right? Be really careful. Yeah, it's a 2x, but it also has this minus number. This one's dropping 14, this one's adding 8. So when that minus 14, that plus 8 happens, this one actually ends up being half as big. So if I wanted to find out how big x was, what do I do with that inside number? This one needs to be, or then I do something else. So I'm going to double this. When I do, I get 4x minus what? 28 equals what? Subtract the x. So we get 3x. Add the 28. That cancels and that cancels. When you add 28, you get what? 36. Divide by 3. X equals 12. But again, that's not the goal. The goal here is to take that and plug it into which one? VU. And when I plug it into VU, I ignore that 2 on the outside. I only look at what VU was initially. So 2 times 12 minus 14 is 10 again. Have you ever taken a test you had the same answer like 3 times in a row? Do you like go back and try the problems again to see if you screwed up? Yeah. You couldn't because you're confident. Okay, last one. Try part F on your own and then we're done. And we're going to do the whole like take turns coming to the board thing. And the rule is you can't pick anybody on the first row because I think they were picked on a lot last time. The first row, off limit. You're welcome. Just try it. You never know. Somebody might pick on you. Before Allie goes up, before Allie goes on, the extra score, nothing happened there, right? Just put it down. Now, the mid-segment 4x minus 13, are you okay with the 4x minus 26? What happened between the picture and the line? What did you do? You doubled it, right? Okay, cool. Almost. If the question said find x, you would be done, right? So what does it ask you to do? Find J and L. Oh, sorry, that noise. Okay, thank you. Okay, two things. First one. Okay, first one. There we go. 20 minus 57. Really quick. What did we find here? Every question so far we found the mid segment, right? Is that what this question's asking for? Okay, so is it okay that we found that to be 7? Yeah, that's fine. Because quickly we can find this one. Double of 7. 14. It's just the only difference was what the question was asking for. So, yeah. Alright. How do you feel about it? Yeah? Okay, I think it's time to work on the assignment, and I will come around and I'll help you feel a little bit more than shaky on it. That's it for today. Thanks for watching. Peace out.